Thank you, and thanks for the opportunity to speak to you guys. My apologies for being late. Some of those integrated livestock decided to have some calves, and it kind of gets in the way of some plans sometimes. So anyway, yeah, as you mentioned, first and foremost, I guess I always call myself a farmer first. It's been sort of my passion all my life. And one of the big things I guess I often say after university is sort of when the learning actually began, where you learn to learn at school and you learn to analyze things and critically think and that type of thing. And then actually being on the fields I've always valued as very important to be the one sort of doing the operating of different pieces of equipment over the year to make sure I cross every field a couple of times, every foot of every field. And the things that start to cross your mind, just thinking about what you're doing, thinking about why does this spot look like this, why does that look like that, look at this row, what is that row, I mean even comparing row to row, comparing really close spaces in fields, that's always intrigued me to try and figure out what those differences are. So after I graduated university in '97, degree in agriculture and mechanized agriculture, with a minor in soils, so those were sort of my interests. I did some consulting on plant nutrition with a company called Western Ag, so basically a different method of soil testing, I guess, and helping farmers with their crop nutrition plans, management, that type of way. Migrated from there into variable rate, became intriguing as to how to do that, so I guess thought about that for a long, long time before we actually started doing it, but also in about 2004, I guess it was, we began our intercropping. That's when we did our first intercropping that year of peas and mustard, and had set up sort of on-farm check strips, had some really good observations. Again, all of my learnings and experience when I discuss intercropping or my theories or any of that, I rarely can back it up with scientific evidence. Sometimes there's been studies done. Only lately the research farms have really started doing studies and oftentimes being able to show results that are similar to what we've seen over the years and what we've observed. But really my own learning has been focused largely on just observing the different spots of the field and relating those. So every year we have a dry year somewhere within the field. Whether it's saline patches, I mean, those areas die because there's not enough moisture available to the plants. So you've got drought stress on the edge of that every year. You've got wet areas in the field every year, that low spot, where you get good yields there. So every condition exists all the time. You just have to go find them and observe what happens, and then you have a better idea what's going to happen. When it's a wetter year, those areas just expand, and on a drier year, they shrink down. That's all. So that's really been a focus of our learning, to try and see what happens and observe those situations, to get multiple years of data in one year. So I guess that's what's led us into really observing the intercropping over the years, finding out things that click together. Observations, pests are one, for example. You can confuse them. So understanding the habits of flea beetles were the first example that we observed. When we had the check strip of straight mustard, and then the rest of the field was peas and mustard, the flea beetles would move out of the area of intercropping and were just thick in the check strip. So it ended up being sort of an unfair yield trial because they all moved into there and put more pressure on the mustard. But it also did definitely taught us the benefit of that. So rather than having to spray or even treat the seed, in a lot of cases the mixed crop is sufficient to confuse the flea beetles and have them move out to the neighbor's field, I guess. We've seen that observation year over year over year, very common. I've had fields where we had untreated seed. We were surrounded by the neighbors with monoculture canola. I couldn't find a flea beetle in my field. They would leave, they would bite the other canola, they would die because it's treated seed, and yeah, we never had an issue at all. When we had intercrop fields without treated seed on my own farm where I was surrounded by my own farm, then we saw more damage because there was nowhere else for them to go. So they're migrating into the field the same rate that they're migrating out. In those cases, then it becomes a question of whether it's worthwhile treating the seed or not. There's there's more damage in that case. Not as much as it would be with a monoculture, though. The same observations we saw with aphids then in the lentils. That was in 2016, actually, in our area. Guys were spraying all their lentils and some of their peas for aphids, and I was out there looking for them in our pea canola lentil crop, and I couldn't find them. So I was on the phone on Google and trying to see what an aphid looks like, because I thought I must be dumb, because everybody else is talking about how easy they're just crawling, and I couldn't find them. So finally I walked into a neighboring field of straight lentils and walked out, and yeah, they're covered on my legs and my shoes, and they were solid in there, like they said. But in the other crops, I couldn't find them. I had to search hard to find them. So because the lentils were hidden under the canopy, the aphids didn't move into the field, didn't fly in. They thought it was a canola field, and they left it alone. They stayed in the other fields. So there's certainly a lot of those factors. For insects, disease is the same way. We've seen, and chickpeas are the perfect example there, where we've been growing chickpeas with flax for a number of years now, I guess. And we like to do that in alternate rows. The rest of the crops we mix because of research and experience, but the chickpea flax we do in separate rows due to the fact that we line up the rows as basically as a firewall to stop the airborne spread of ascochyta spores from plant to plant. We found through that, same thing, we've got pictures and observations where we find a diseased plant, and I'll flag it, and I'll come back to it later. And normally the disease pattern that you'll find with ascochyta is it spreads out in an oval shape, mostly in the direction of the predominant wind. When we've seeded the field on an angle against the predominant wind, when we came back out, we can find one plant that's highly infected with disease. The plants next to it up and down the row will have some incidence of disease, and then you jump across the flax row to the next chickpea plant and you can't find any. So it's stopping that spread of spores, whereas otherwise it would spread like firewall. I mean, it basically is the best term or example I can think of for that. So we're not stopping the disease or the disease incidence. If you seed plants that are infected to start with, you're still going to have that same rate of infection, but we can stop the spread and greatly reduce the speed of the spread of the disease, which then gives you a lot larger window of tolerance before you have to intervene. So we've found over the years, we don't even think about spraying our chickpeas with fungicide until a monoculture would be on their fourth pass. And at that time, when they start having to hit the fourth time, if it's a wet enough year, then we start considering doing them once. And with them doing mixed with alternate rows like that, we've never had to spray them more than once in a season, where we've had years where neighboring crops have been 7 applications. So huge cost savings there, improvement in grain quality, and obviously great increases to the bottom line as well as sustainability. When you start doing 7 passes of fungicide in a year, ascochyta resistance to the strobies are going to develop very, very quickly, and then we're not going to have any tools left. So being able to not spray it in most years and then having to use 1 application on the odd wet year is going to give us a lot longer life of that tool. Same type of thing with weed pressures. So this is something when I speak with organic growers, obviously is a main challenge that hits very closely with them is often weed control. And as they're well aware, I like speaking with organic growers because the only tools they have to control weeds, pests, and diseases are agronomic tools and agronomic practices, whereas, I find a lot of other growers, oftentimes we've kind of forgotten that because we grab the tools first, right? We grab the quick fix or the chemical solution first instead of that being the last choice. So anyway, the organic guys, we're looking at weed. The big thing to compete with weeds is having a more vigorous crop, and have more vigorous crop can also be crop density. So increased seeding rates. This always brings the question of what is the ideal seeding rate in a monoculture. Why is it where it is? Because if we go any higher, we're going to introduce problems like lodging or disease, those type of things, or just too much competition for the limited resources, because the same plant is going to want the same resource at the same time. When you introduce polycultures and have more different crops, now you've got different crops competing in different spaces for resources at different times. And now you can increase that seeding rate because that overlap isn't necessarily the peak demand point. Increasing the plant population will increase the competition with weeds, because it also broadens the spectrum of when your crop is using the resources, which means there's not that window of underutilizing resources, and that's what the weeds are taking advantage of. If there's no opportunity for a weed, it won't come. The reason why you get a weed flush is because the seeds have been triggered because there's an opportunity, whether it was moisture, sunlight, timing, day length, all these different factors will trigger that seed to germinate that year. If we have more crops there with more diversity that we're able to better utilize those resources at each point of the year, it's going to compete better with the weeds for that timeline. So every aspect basically makes more sense to this. When you look at nature, you just go out there and look, you're not going to find a monoculture existing nearly anywhere. The systems always want to go towards diversity, and that's for that balance of optimization of resources over different times of the season. There's always, it's just capturing that opportunity and making use of it. So, we've certainly seen a lot of advantages. Now, why people aren't doing it? Historically, agriculture did do it, but mechanization and scale, efficiency of scale, those would be the arguments against it. A simple system, large mechanization. Now, that's what led me into some of the other things like the Clean Seed Project or whatever, was to improve the mechanization, improve the logistical management so that we're able to manage and handle more different products and do more different things across the field. So some of what we've done, I guess, incorporating all of the variable rate aspects that we've learned and incorporated onto the farm now, mapping fields based on soil, water, and topography, the intercropping experience, and observing these different areas, our system has now adapted to where we're doing 3 crops on a field, and then we change the populations of each crop depending on the area of the field. So canola pea lentil, for example, the lentils are the dominant population on the hilltop, where the peas are the dominant population in the low spots, and the canola will be sort of spread throughout, and will actually increase the canola population in the saline spots because of its increased saline tolerance, and to try and make use of, try and uptake some of the sulfur in that area. So that's some of what we're doing by changing the crop types by different area of the field and managing those together. Certainly there is large-scale equipment to make it happen. We have to consider harvest. Most of the crops we put together, especially pulses and oil seeds, those type of things, very similar as far as combine settings, easy threshing crops, ones that don't have a problem. Chickpea and flax, it's actually interesting. The chickpea is what threshes the flax. So we can set our combine very gentle, and the chickpeas themselves will thresh the flax balls better than we ever could in a monoculture crop. So they're just a very abrasive seed. So that actually just really worked out well for us and was kind of lucky on that front. But if you don't have enough chickpeas in the population, like if you ever shut them off, your combine setting won't thresh the flax at all. So there's a lot of things to consider and work out. Timing of crops we deal with, we try and make sure that the first crop to be ready is going to be one that's not grade sensitive. So things like red lentils are good. Flax is another beautiful one. So if they're ready first in those 2 examples, they can just stand there. They can take a rain. They can take whatever. They're not going to downgrade. It's not going to be an issue for us. They'll wait till the crop is ready. Most attributes have always worked out well for us. Things like the pea, canola, lentil, for example. The peas tangle up the whole crop into a they tie the canola and the lentils all together. So if you're going to straight cut it, we've straight cut open pollinated canola varieties or mustard types in that situation, and they won't shatter because the peas have it all tied up, so it's a tangled mess. The plants can't smash into each other when the wind blows. They're tied up very well. If you swath it, the swath won't blow away because, again, it's a very nicely knit, tangled. And also the canola helps to create some air through the swath. So if you do swath it and it gets rained on, it's not like a lentil swath that goes flat to the ground and never dries out. They're mixed in with the canola, which gives it some air pockets throughout, and they can dry out again very quickly and help the grade there as well. Some of the challenges, I guess, that I've seen is among other farmers is trying to figure out logistics. Really has been the big challenge. So first of all, there's two things. They'll choose to sort of either not look at the economics or not trust them if they've never tried it that way before, and so they don't adopt it because they can't get their head around logistics to do it. So I guess some of the industry help really needs to be in presenting ways of managing and ways of being able to do these crops, both at seeding and at harvest, I guess, are the keys. So, cleaning technologies. I know we struggled with that the first few years. We've got a system worked out that works very well for us now and keeps up with the combines, but that was a challenge at first because most grain cleaning plants are all designed to clean a product, and they're only designed for a small amount of tailings. In this case, you're often trying to separate a product, and it might be 50-50 volume. So both product streams are important to you, and a lot of cleaners aren't designed to handle that. So every one we've used has required some modifications. The research end, definitely, just more research confirming things, trying to figure out theories. I would really like to see research come up that focuses on areas of the field. So more of a variable rate research approach, I guess. Like oftentimes we get data from small plots, and you don't know. I mean, you can get the rainfall data, but you don't know if that was a highly productive zone of the field or a low productivity zone. Oftentimes we will try on our farm to find results that are meaningful for us. I'll look at Swift Current and at Melfort to try and say my drier areas and my wetter areas of the field and compare that to their long-term research trials from each of those. But it would be nice to see them do some more of that, I guess, type of thing. Research trials done in saline areas. What do we do with those spots of the field? Hilltops, low spots, flood-prone areas. What varieties, what practices, what things can be done best in there? And even relating that as intercropping. If we know that one crop is more yield elastic to water or yield elastic to fertility or, whatever that trait is, then you're going to know which crop to try and position in which area. If you're only going to lose 10% of a flax yield by putting it in the poor areas of the field, you're going to put it there. If you've got a very yield elastic crop that's going to give up all its yield in those areas, then you're best to not put it there and put something else there. So that's where the mixtures and stuff can really pay, I guess. They complement each other over the growing season, and then if we can put them in different areas, we can really capture that again, is where we've been trying to go with it. So to inspire researchers to really push the envelope and go beyond just putting two crops together and doing it would be good. Certainly industry, there's a place for industry and grain handling to possibly even buy mixed crops. There's an opportunity to help farmers with that. They could store them together and buy them together. We've started as Three Farmers, which is a company that I'm involved with that buys camelina oil, or buys camelina, I guess, and makes camelina oil as well as chickpeas and green pea snack foods. But we put out this year the first production contract that specifies intercropping. The reason we did it is because of our own experiences growing camelina. First of all, it made harvest way easier when we intercropped it with lentils. And the second reason was that our oil quality, we're testing our oil quality all the time because it's a food-grade product. The intercrop fields, we found higher oil yields and dramatically improved quality of that oil because of that plant health. So it was a really interesting factor that we never would have seen if we hadn't been directly involved with with the fact that it was a traceable product that we were tracing through from the field, and we were testing every lot as it goes through processing. And we repeated that over 2 separate years now, so our production contracts are actually specifying that. So those are some interesting things, I guess, for the industry to consider and take a look at. If they're measuring quality, improved plant health from intercropping can result in improved quality of your product. So there can be a reason to push that through from that end as well. Yeah, the logistical end, I guess, is kind of a bit inventive, really, to come up with, and we've created some things without showing you pictures, I guess, and stuff, how we've gone with overhead cleaners and grain handling system, but as guys get common, I think that end will come as production goes there. I'll maybe just stop there and take questions from here, I guess, and we can lead into whatever areas we want to learn more about.